Alright, an aircraft is heading due east. Air traffic control tells the pilot to turn left onto a heading of 355 degrees. Through how many degrees will the aircraft turn as it changes direction? Okay, let's draw our directions here. North at the top, south down here, east to the right, and west here. Now the aircraft is heading due east. So that's the direction it's going. And he's told to turn left, so he's going to turn his plane. If this is a top view looking down on the plane, he's going to make a left turn and go in a different direction. And he's going to end up at a heading of 355 degrees. So a heading of 355 degrees, now what does that mean? Headings, remember, are measured clockwise from north. And 360 degrees would be a full rotation. 360 degrees would be north. He's heading at 355 degrees, so that's almost a full rotation, but not quite. 355 degrees, that heading is 5 degrees west of north. So that little angle right there is 5 degrees. Let me just make a note of that. 355 degrees is 5 degrees west of north. So through what angle is the aircraft going to rotate? That's this angle. And you should be able to see from the diagram that that's 90 degrees between north and east, and then 5 more. So he's going to turn 95 degrees to the left. The calculation is basically trivial. 90 plus 5 is 95 degrees. And one more. A ship is headed directly east. So that's the direction the ship is moving. And is headed directly toward a lighthouse that is 300 meters away. So this is the lighthouse over here. And we're given this distance from the ship to the lighthouse is 300 meters. Then on the charts of the harbor, the ship's captain notes that dangerous rocks extend 70 meters south of the lighthouse. And we see that marked here. So this distance is 70 meters. That's the edge of the rocks down there. On what heading should the ship travel to avoid the rocks? So the ship has to turn to the right, and he's got to go in a direction that is going to clear the rocks. So let's imagine that he's just barely going to clear the rocks. If he were to just basically just slip by, so we get a right triangle here. That direction is east, this is south, and then this direction the ship needs to go gives us the hypotenuse. And we're trying to find the heading that the ship needs to go. Okay? Well, in this right triangle, we can call this angle here theta, and we know the side opposite theta is 70, and we know the adjacent is 300, so we can say that the tangent of theta is 70 meters over 300 meters. So if the tangent of theta is 70 over 300, then theta has to be the inverse tangent of 70 over 300. And actually, if I write meters right there, I should write meters here, but they're going to cancel out. So 70 over 300 is our calculation, or the inverse tangent of 70 over 300, and the calculator tells us that's 13 degrees. Now 13 degrees isn't the answer to the problem. 13 degrees is this angle. We were specifically asked on what heading, and the headings are measured clockwise from north. So if we say the ship is right here in this position, let's imagine a little north, south, east, and west right there. The heading is going to be this angle right here. And you can see this in this diagram that between north and east is 90 degrees, and then we have this many more, theta more degrees, or 13 more. So the answer has to be 90 plus 13. Comes out to 103 degrees. So he needs to go on a heading of 103 degrees or more to clear the rocks. And he actually wouldn't go on a heading of exactly 103 degrees. He would give a little bit of room, a little bit of extra clearance there. but this is the absolute minimum that he needs as far as the heading that he goes in order to clear those rocks.